In this clip we start a new topic which is quite a central topic in linear algebra, and it's vector spaces. It's quite theoretical, so we'll take it nice and easy and introduce it slowly. As you can see, it's made up of two words, vector and spaces, and first of all we'll talk about vectors, and not just any old vectors. That's still too general. Let's narrow it down to three-dimensional vectors, 3D for short. And before that, I want to talk about what is 3D space. And here's a picture which is going to help me to explain 3D space. Notice these blue lines with the arrows. These are axes. Notice that there's an x-axis, a y-axis, and a z-axis. That's three axes, in contrast with high school, where you probably just had two axes. Maybe there was an x-axis and a y-axis. It was good for describing the flat world, the 2D world. But in real life we live in a 3D world, and so we need three axes, x, y, and z, if you like, width, length, and height. Now, when we were in a 2D world and we had a point, it was described by two numbers. We dropped a perpendicular here and one here, and this was the x of the point. Maybe this was 3 and this was 4. So when we would say this is the point 3, 4, and that would do it. But in three-dimensional space, well, let's take this point here. We call it P. It needs three coordinates, an x, a y, and a z. One way to do this is just to drop a perpendicular into the xy plane, which is this one here. And we see that for this point here, for example, then x is 2 and y is 3. So we start with 2, 3. But then we also have to go up, and that would be 5 units. This was meant to be parallel with the same height as this. So we need an x, a y, and a z for the three-dimensional world. As another example, let's take this point here. We can see that the x is 2, the y is 3, but since we don't go up at all, we stay in the plane, the last component is a 0. Another example, this point here. If we drop the perpendicular down to the xy plane, we see that it's at the origin here. So the x is 0, the y is 0, but the z component, we go up 5, is 5. So that's an introduction to 3D points, but we want 3D vectors. Now, let's take this point. Corresponding to each point, we can take a segment that joins the origin to that point, like so, and with a little arrow on the end. And this is the line segment with an arrow that takes me from O to P. O is the origin. So associated with this point, we have this arrow, and this is the vector, and we call this the vector OP, and we write a little line with an arrow on top. And OP is denoted with this kind of brackets, 2, 3, 5. So points are written with round brackets, and vectors, which are arrows, are written with angular brackets, although I must say that some books use round brackets here also. So it's not standard. In this course we'll use angular brackets, not round brackets. And sometimes we just want to give a single letter name, a variable name, to a vector, and typical letters would be U, V, W, just like variables are X, Y, Z, and constants are A, B, C. So I could say, in this case, that U is the vector 2, 3, 5, and it's customary to put a line underneath. And let's take another example. Draw the line from the origin to that point and put a little arrow at the end. And this is now the corresponding vector, and as a vector we write it as 2, 3, 0, the same numbers but with a different kind of brackets. And also this example, and here's the line with the arrow at the end, and this would be the vector 0, 0, 5. And let's give them names. This one, well, we use the letter U. Let's call this one V. And this one we'll call W. So here are three examples of vectors, 3 points and their associated vectors. It's sometimes called the position vector of the point because it tells us where it is relative to the origin. The 2 means we start from the origin and we go 2 units in the x direction. And then the 3 here means we now go 3 units in the y direction. And 5 means we now go 5 units in the z direction. So 2 this way, 3 this way, 5 this way, and we get to the point. That's basically what a 3D vector is. It's a vector which joins the origin to a point in 3D space. And let me just summarize in writing some of the things I said. So again, in our example, this point here, 2, 3, 5, in the three-dimensional world can be viewed as an arrow with a tail at the origin and a head at the point P. And the arrow is called the vector OP, and we write it as OP with an arrow on top and equals the 2, 3, 5 like this. Or we give it a letter name, typically U, with an underscore. And sometimes instead of the underscore, we write it in boldface. And sometimes just as a regular U, we get fed up of writing the underscore all the time, so we just call it U. And now